Hey guys, how's it going? Today's topic of the video is gonna be object cloning. Now, there might be a case where we have an object and you know that there might be changes to the given object. So you decide to save the current state of that object by creating the copy, the clone. I'm gonna be demonstrating 5 different approaches to successfully clone object in JavaScript. Now, those 5 approaches are spread operator, rest operator, Object.assign method, JSON.stringify, parse method, and for the last, I'm going to show you custom recursive functions using loops to deep clone objects in JavaScript. So now let's begin. Now, in the previous videos, we talked about spread operator and rest operator, if you remember. Now, these are basically the new additions to ES6 JavaScript to easily destructure objects into individual elements. And how are they useful in our case? As you can see, it's pretty simple to simply destructure object and create the clone. So in this case, we are creating the clone using the spread operator. We are simply destructuring this object, this simple object, and the clone is the method1 variable right here. Let me show you here. The method1. As you can see, the simple object and the method1 are basically the same. But now here's the thing about the cloning. If you remember from the previous video when we talked about the comparison between the objects, when we said if the equation returns true, let's say method1 equals to simple object. As you can see, it returns false. That means the cloning was successful. So this object right here refers to different object in the memory location and the simple object refers to different one. So in the memory location they are the different objects. So one change will not reflect the other. So if I change the method1's dot prop1 equal to 2 and let's check it right here, the simple object is not going to reflect that change because it's completely different object in memory location. Now, cool thing about the spread operator is that you can simply add or update properties. Let's say I want to add, I'm gonna name it spread, and let's say I want to add a new property called prop3 and give it value, let's say new value, and I want to change the prop1 as well, prop1, which is going to be 3 to 1 and it's going to be string. So now the spread variable is technically the clone of simple object, but we changed some of the properties in the way. We changed prop1 and we added a new value. So that's cool about the spread operator. Now let's see the rest operator. The rest operator is used to retrieve the values from object, but in this case it's completely fine to use it as the cloning. So as you can see, we are successfully retrieving all of the properties from simple object and saving it inside the method2 variable. Now let's see right here, method2, and as you can see, everything is exactly the same. Now the cool thing about this rest operator is that you can skip some of the properties in the way. Let's say, I'm going to copy this right here. Let's name it rest. And now, let's say I want to skip prop2. It has to be the last one actually. Right here. So, as you can see, the prop1 is going to be removed from the rest variable. And it's only going to retrieve the prop1. Now the really cool thing is that you can use both of these methods. You can use spread and rest at the same time. Now I'm going to show you right here. So let's say I want to skip prop2 again. I want to retrieve all of the other values here, but instead of retrieving all the values from simple object, I'm going to add some of the properties here. Let's say the new property, which is going to be the new value. So I'm going to have to move it right here. And as you can see, it's done. The new property is added using the spread operator right here. The prop1 is retrieved from simple object and prop2 is actually skipped. Oh, I actually used the wrong name, so it didn't quite work the way I expected. Let me do it again. It's not prop2, it's prop2. So the rest should look something like this. So we skipped the prop2 and we retrieved the prop1 from the simple object, and we added the new value right here, the new property called new prop. So the third method is using Object.assign method. So this method is basically merging the second argument from this function into the first one. So let me show you right here that it's successful. Method 3. So it's basically the same, but the cool thing about Object.assign is that you can add or update properties just like in spread operator. So I can basically do like this. I can add the new prop, just like on the previous example. New prop and new value. And now if I show you method 3, it added the new value right here. And also you can update properties just like in the previous case. So the fourth method is actually one of my favorite methods, and it's one of the fastest methods, but it has its downsides. If you don't know, the JSON.parse, JSON.stringify method is quite dangerous if you don't know what you're doing. You might lose some of the data which is not JSON friendly. For example, the functions inside the objects will be lost, just like undefined symbols and all the other data types that are not acceptable for JSON. So be aware of that downside, and I'm gonna show you just now how it works. So basically we are simply creating the JSON string right here. We are turning this object into a JSON string, and then we are using that given string to recreate the object using JSON.parse. JSON.parse simply takes the JSON string and creates the JavaScript object. So I'm going to show you right here. So it creates string, and JSON.parse simply takes that string and turns it into an object. So let me copy this right here. So yeah, it creates the object using JSON string right here. Now all of the methods that I just shown are basically shallow cloning. So what is the shallow cloning? The shallow copy will duplicate the top level first layer properties like this. So this right here is the first layer, basically the top level property. This one is the top level property, but the nested object is shared between the original and the copy. So what does that mean? Let's say I have the prop3, which is the nested object. So this nested object is basically not gonna get cloned, and the reference will be given to the clone object. So let me show you right here. Let's say I have something like this, the nested object, sits object, and some string. So let's say I clone this, gonna refresh, and let's say method 1 and method 2. Now the method 1 has this property 3, and it's good, right? Nested object, and it has the same thing as well. But you might be expecting that whenever we change the method 1's prop3's value nested object to something new, updated, let's say, that the method 2 should not reflect that change, but you're gonna be wrong, because the method 2 and method 1, these two variables, share the same object. Now this nested object is shared between these two variables. So if I check the method 2, oh, it's actually method 2. Now the prop3 is gonna reflect the same change. It's updated, as you can see. So that's one problem using the shallow copy methods. Now these four methods are all shallow copy except for JSON. The JSON is simply stringifying the object and then parsing back. So the reference has nothing to do with it. So the reference won't be retrieved in the new clone object. So these three methods are shallow clones, and this is a deep clone. So the deep clone in this case means that you are cloning the object and the nested object itself as well. But you should be aware of the data loss, because the data types that are not friendly for JSON will be lost, such as functions and other data types. And I'm going to show you right here. Let's say I have some function property, prop4, which is function. Return function. Some string in text. So let's see it in the example. I'm gonna refresh and let's see method 1. As you can see, the function is saved right here, but in the case of method 4, which is JSON, function is not saved because function is not JSON friendly data type, and it's gonna be lost, just like undefined and all the other data types. They are not friendly for JSON. So now this takes us into another problem as well, because the JSON simply stringifies the object and it's not considering the descriptor of the property. If you remember from the previous videos, we talked about the object property descriptors, which basically allows us to change property more precisely using enumerable, writable, and configurable. So let me show you right here. Let's say I change the prop1 to be enumerable false. Or for the first example, I'm going to show you writable, which means that I should not be able to change prop1 whenever I try to. So I have to refresh. So let's say I try to change the method ones.prop1 into something else. Let's say I want to change it to 99. So basically this should not be possible, and it's not. As you can see, the method 1 changed, so the clone is not going to take descriptor into consideration. Now if I try the same thing on simple object, let's say prop1 equal to 321, now this should not be happening, and it's not, because the writable on this object is set to false in the prop1 property, but in the clone it's ignored, which is problem for the second method, the third method, and on the fourth method as well. All of these methods are really bad if you are using object descriptors. Now let's say I change enumerable into false. Now what do you think is going to happen? Surprisingly, the prop1 won't be shown in all of these variables. Let's see right here. As you can see, it only shows prop2 and prop3. So what is happening is that the spread operator, the rest operator, Object.assign method are using iterations to achieve cloning. So when you set enumerable to false on prop1, the loops can't access property 1, and it's simply ignored when creating the new clone. So keep that in mind, and this problem is taking us into the next step, which is using custom functions. Now, why are custom functions useful? Now, let me show you right here. Now, let's say I have some constructor function named myClone, and it's creating clone name, age, object property, array property, job, null, and undefined. So, as we mentioned before, this tree is gonna be lost if I use JSON.parse, and let's say I give it a prototype. The prototype is gonna be lost as well, because all of these methods are simply copying properties from the object and putting them inside the new clone, so the property won't be taken into consideration, and it's gonna be lost just like the descriptor in the property. Plus I have nested object, as you can see right here, and the nested object will be lost as well if I use any of these methods. Or it won't be lost, it will be referenced to the same object, so the nested object will be shared between the clone and the original object, which is not the desired behavior. So how do we deal with this? Now let's say I create this object, I give it a prototype, and I give it all of these properties. So I'm gonna refresh, and let's see object 1. So the object 1 has name, age, the nested object in itself, which has the function in itself, and it has property which is 1. And also it has the prototype, which has the hello function. So I want to create the clone which has all of these properties, all of these methods. The nested object will also have to be cloned, and the prototype should be the same. So I have the access on the hello method. Now how do I do that? We are checking if the value of the property is an object, and if it is, in this case, like whenever we go to object property, we check if it's an object, and if it's true, we are simply using the same function to recursively clone the object. So this function is a recursive function. If you remember from the previous videos, now the recursive function is simply the function that calls itself during its execution. So we are calling this function during the execution if necessary. In this case, if the value is object. So whenever we go to the object property, we are simply calling the deep clone function once again to clone all of these properties inside from the nested object to the new property inside the clone. And if it's not the object, we are simply taking that property and putting that inside the clone. And finally, we return the cloned object. Now, this line right here is not necessarily if you don't deal with arrays, but if you are expecting that some of the properties are gonna be arrays and you want to clone them as well, this right here is a good choice. But this function lacks one thing, which is property. Now, let me show you right here. If I use the deep clone to clone this object, let's say clone 1, and it's gonna clone this object right here, object 1. Now, let's see object 1 and see clone 1. First, let's compare these two, if they are the same. And it's false, which means it's successful. It's a good sign. So, what are the differences between these two? Let's see right here. The name is exactly the same, age is exactly the same, the array is exactly the same, and the nested object, which is right here, the object property, let's see, object, is exactly the same, but it's successful because, let's say I change the object 1's object property, p property, into something new. Let's say 1, 2, 3. Which is currently 1, and if it's successful clone, the change on the p property inside the nested object should not reflect on the other property inside the clone. So let's check if the clone object property has changed, and voila, it's not. It remains the same. So the deep cloning went successful. But there is also one more problem, which I forgot to mention, which is prototype. Now this deep clone is gonna work perfectly well to deep clone the objects, but it's not gonna keep the prototype right here. So the object 1, let's clear this. So the object 1 has the hello function, which is good, right? And it should be, because it has the hello method inside the prototype. But there is one problem with this function, deep clone, which is prototype, which I forgot to mention. So if I use, let's say I clone using deep clone, once again, object 1, now this 2 is gonna be exactly the same, but as you can see, there's something wrong with these two objects. Now, can you spot the difference? It's right here. As you can see, the hello function is the function of the prototype, and it should not be inside the instance. But this function does not respect it and simply takes that method and puts it into an instance, which is not what we expected and which is not what we need. This is completely different object now, and this is completely different. we should be able to take the prototype and set that prototype as the prototype of the cloned object. So this clone1 should have the prototype with the hello method, just like this. The prototype should look something like this, but it's not. Which takes us into another function right here, which I prepared for you, deep clone with prototype, just so you don't get confused. And I'm going to show you now how it works. Actually, we are checking if it's null with something like this. If it's equal to null and it's not the type of object, we are returning the object. And now this case right here is for the arrays, and I'm not going to talk about it just now. I'm doing this to avoid some errors because we don't want to copy the prototype of an array and set it to a cloned object, and we have to handle the arrays differently like this. But let's just ignore this for now and focus on this part right here, what is happening right here. Now, if you remember from the previous videos, Object.create method takes the first argument and sets it as a prototype of the newly created object. So we are simply creating the new object, which is the clone object right here, and we are setting its prototype to the given object's constructor function, which is this function, maclone, that we created this object, and using that function's prototype. So the prototype of this, the maclone's prototype, is gonna be set to newly created clone's prototype. And after that, we're gonna iterate over that object and set every key to the given value. So we are simply using the recursive function once again, but in this case we are using the prototype from the previous object, from the original object, to keep the main structure. So let me show you here the example. Let clone1 equal to deep clone with object and object1, which is the name of this object right here that we created. So let's see in the example, object1 and clone1. Let's open this too, and as you can see, the problem is fixed. Now the hello function is not simply copied into the new instance, and it's taken into the prototype. So the clone and the original object share the same prototype, like this. The prototype has hello method in both of these instances, and all the properties are exactly the same. They are copied, and the good part is the nested object is also fixed. As you can see, object1 dot obj dot p equal to something new, and the clone should not reflect that change if it's successful. Object dot p, which is 1, it didn't change, so it's a good sign. Now in the array case right here, it's simply taking the array. First we have to check if the given argument is array by using instance of, like this, an array, and if it's an array, then we use slice method on the array, and then we use while loop to simply loop over the array and save every one of the property, every single value inside the array into the new array right here, and then return. So not only we are deep cloning the object, we are also deep cloning array using this right here. But there are some edge cases when the given property is not taken into consideration. Let's say date object, or regular expressions. Now those kind of objects are really different and need to be handled differently. In that case, you just have to simply check for the edge cases like this, put it right here. Let's uncomment this. So if the given property inside the object, original object, or the whole object itself is the date, we are simply returning the new date and getting the time from that. So all of the edge cases need to be handled differently. Now in the case of regular expressions, you just have to create the new regular expression right like this in order to clone the regular expression object, or simply not mess up the property of the original object, which has regular expression as its property. So yeah, that's about it. There are also another ways that you can achieve cloning of an object using external methods like jQuery.extend or load-clonedip function. But those functions, despite the fact that those functions are reliable and useful and millions of people use it, the custom function with all of the requirements to perfectly clone the object is good to go. But you can use it if you like to. So yeah, that's about it in this video. See you later. Bye.